Let's consider this picture of an exponential function, f of x equals 3 to the x power. I want you to notice that you're given 2 points in this graph if you look very carefully. One point is at 0, 1. That's xy equals 0, 1. And the second point is at the ordered pair xy equals 1, 3. Now keep that in mind because we're going to use translations to do a variation of this graph, and we want to remember those 2 points so we can make changes to them. We're going to use this sketch of f of x equals 3 to the x, and we're going to use the graph variations that were described back in note 74. So go back and review note 74 in order to sketch this new function called g of x, which is defined to be equal to -4 plus base 3 raised to the x plus 2 power. And we're asked to identify the domain of this function g and the range of g. That will be easy to do once we have our graph. Okay, so let's get started. First of all, I like to see the exponential part in the front and the -4 in the back. So I'll just rearrange that. G of x equals 3 to the x plus 2 power minus 4. Now, let's see. The first variation I see from the basic graph. Now, the basic graph is the picture at the top of this page. It is the f of x equals 3 to the x power. Okay, so the variation that we have to the x coordinate, you see, is a plus 2. So what does that mean? We're going to take our basic picture on top and we're going to shift to which direction? We're going to shift left 2 units. Okay, now remember, whenever we make changes to the x coordinate, we shift to the opposite direction than we would assume. So we're adding a 2, which means we're shifting to the left. So the ordered pair xy will change by subtracting 2 from the x coordinate. All right, you'll take all the x coordinates and subtract 2, and then leave the y coordinate alone to get the new position. Then the next variation to the basic graph that we see on top is going to be due to the -4. That will cause us to shift in the downward direction 4 units. So any ordered pair xy will be changed by subtracting 4 from the y coordinate and leaving the x coordinate alone. So we're going to do this graph by first drawing the basic graph. This is the graph of y equals 3 to the x power, and sure enough, there's our 2 points, 0, 1, and our next point, the ordered pair 1, 3, right there. Okay. So there's our basic graph that we're starting with. Now we're going to make our first variation. Now this variation is based on the adding 2 to the exponent, just adding 2 to the exponent, which means we're going to take each of the ordered pairs that I just mentioned, and we're going to subtract 2 from the x coordinate only. Here's our y-axis and our x-axis. Now, when we subtract 2, it means that we are going to get the ordered pair, which originally was 0, 1, will now become -2, 1, right here. And the ordered pair that was originally, 1, 3 becomes -1, 3. And we have this picture. Now, I want you to notice, even though I didn't mention it, you can see clearly what we have is an asymptote at the x-axis. It doesn't touch the x-axis, it just keeps getting closer. Okay, so later I'll come back and put a dotted line on that x-axis to emphasize the fact that we have an asymptote here. All right, now we're going to shift everything 4 units down for our last variation. And when we do that, it's the same as subtracting 4 from the y coordinates. Okay, and we're even shifting our asymptote down 4 units, okay? So the points come down 4 units, the 2 points in question, and the asymptote comes down, which used to be the x-axis. It comes down to -4. So we'll be drawing a dotted line there for our new asymptote, and we connect the dots together, and here's the picture of our final product. Now, it would be a nice idea to go through and identify the points that we changed. So in the second graph, we had -2, 1, and we had -1, 3. And that became, in the last graph, let's see, -1, -1, and -2, -3. And of course, the asymptote came down. And that's the picture of g of x equals -4 plus 3 raised to the x plus 2 power. Now, of course, we identify the domain by looking at the last graph and seeing that we only have x values starting out at negative infinity for x values now, and going all the way up to x equals 0, but not reaching x equals 0, because we also have a vertical asymptote at the y-axis. It never touches the y-axis, and that means that corresponds to the coordinate x equals 0. So we have an open bracket on the 0. So everything from negative infinity to open bracket 0 for the domain. For the range, well, let's see, the lowest y value starts at -4, and the highest y value is positive infinity. We never actually touch -4 because that's an asymptote, so we have an open bracket on -4, and as usual, we have an open bracket on infinity. So that's the list of, in interval notation, of our domain and our range of this new g function.